Welcome to this lesson for Design and Technology. Today we are going to learn about orthographic projection. In this lesson, we will be able to understand what is meant by orthographic projection, identify the principles to be applied in an orthographic drawing, and draw the front, top and side view of simple cuboids and cubes. You surely went through the design process in grade 7, where you were encouraged to come up with new ideas for a pen holder. The concept of new objects are formed in our minds. We then try to communicate our ideas by sketching them out in what we call concept drawings. Professional designers come up with concept drawings a little bit like this. Or something like this. Or even these. As you see, some objects can be very simple and others are quite complex. What about dimensions and details? After these concept drawings, we have to think about how to manufacture the items, and therefore we have to include all details and put their dimensions. This is not easy to do in three-dimensional drawings like for these scissors. So, important dimensions and details are added to two-dimensional orthographic drawings as such. Having a look at this ring that has to be manufactured, you will agree that dimensioning on this picture is quite difficult. On the other hand, these views enable all important dimensions to be included. Orthographic projection is an internationally known and understood convention so that people from any country, such as England, China, and Mauritius, are sitting together discussing, for example, a building to be constructed. They will all understand the drawings and details. It is good to know that before building a house, you need to have a building permit, for which you need to submit details of the house, which are in fact drawings in orthographic projection. This is an example of a house drawn in orthographic projection. The orthographic drawings consist of 3 drawings spaced apart from each other. All these drawings represent the same object. How to draw in orthographic projection? The object should be visualized from 3 different directions. When we look at the object from the front, in the direction of arrow F, we get the front view. When we look from the top, in the direction of arrow T, we get the top view. This is drawn exactly below the front view. When we look from the side, in the direction of arrow S, we get the side view. Now, let us work out a simple exercise. We will work out the orthographic projection of a simple block. In this case, you are given the drawing of this cuboid on an isometric grid. you are required to draw the orthographic projection as per the arrows. How to visualize the three views? Number 1, make as if you are holding the cuboid in your hand. Number 2, to visualize the front, make as if you are holding the cuboid exactly at the level of your eyes and you are looking at it perpendicularly in the direction of arrow F. What shape will you see? Of which color will the shape be? What will be its size? Here is the answer. After drawing the front view, you will now visualize the cuboid from another direction, that is, in the direction of arrow T from the top. What shape will you see and of which color will the shape be? What will be its size? The answer is as such. You will notice that 2 empty squares have been left between the two views. After drawing the top view, you will now visualize the cuboid from another direction, that is, in the direction of arrow S. What shape will you see and which color will the shape be? What will be its size? The answer will be as such. The complete orthographic projection of the given cuboid should be like this without colors. You should make sure that the outlines are drawn in dark, neatly and precisely. The next exercise consists of the orthographic views of a cube. Looking in the direction of arrow F, this is the front view. Looking in the direction of arrow T, we add the top view in green. And looking in the direction of arrow S, we get the side view in orange. You will notice once again that the views are drawn exactly in line. The top view is drawn exactly below the front and the side view is exactly to the side. Therefore, the final answer to the previous question is as such. As further questions, you can attempt these. Match each cube or cuboid with its corresponding orthographic drawings. The answer for number 1 is C. The answer for number 2 is A. And And the answer for number 3 is B. For this exercise, redraw the orthographic views and complete them by adding the missing front view. Note that you can view all of our lessons on the website of the Ministry of Education under the Student Support section. For these drawings, add the missing top view. Here, add the missing side view. Now that you have gone through the first exercises, you can attempt to draw all 3 orthographic views of these given shapes. During this video, we have been able to see that orthographic projection is a drawing commonly used to communicate details on products to be made. In the building and construction industry, orthographic drawings are used to communicate various details such as forms of buildings, dimensions, and placement of features, for example, doors, windows, stairs, etc. This is the end of our introduction of orthographic projection. Remember that you can view all of our lessons on the website of the Ministry of Education under the Student Support Program. Be sure to catch us for the next video on orthographic projection. Till then, goodbye.